Okay, so here we're going to start off by just talking about compound angles, and compound angles go hand in hand with what we call double angles. So it's impossible for me to separate them, right? So when we talk about compound angles, right, this is what we're talking about. Now, the best way to go about this particular section is that you need to know the formulae, right? You need to understand the formulae, meaning that you need to know your compound angles as they are. And in this case, what you find is that the compound angles identities is that it's cos A minus B is cos A cos B plus sine A sine B. Now, how I used to think of cos and sine, these particular compound angles, is that, okay, one, compound with the compound angle of cos is that the only thing that changes is the sign, right? So if in the center the sign was minus, right, in this case where you look at cos A minus sine, so it's minus, will be minus. The only thing that would change is the plus. This is how I used to think about it, right? But then what you do is you just apply the cos as is onto both of them. But you do need the other one, so then you also put sine, right? So that's just another way of just remembering. For me, that's how I used to do it. And then with the sign, what I remembered was that no, the signs don't change, but the order of the trigonometric functions change. So as you can see, then you have it's a minus b, but the minus still stays minus, but then the sign of the trigonometric function changes where it's sine a cos b minus sine b cos a, right? But the order just changed of the a and b in this case, right? With the trigonometric function, right? So when two angles are added or subtracted to form a new angle, then a compound or a double angle is formed. And then we introduce to double angles where we can say that for a single angle, when we multiply it by 2, so it says sine 2a would give us 2 sine a cos a. And with cos 2a, it gives us cos square a minus sine square a, right? And also 1 minus 2 sine square a is also the same to cos 2a. And then we also have 2 cos square a minus 1, which is also the same as cos 2a, right? Which is a double angle. So those are the things that you need to know. And also you need to remember your cofunctions, your reduction formulas, so that you're able to do these questions quite effectively. But let's start off with an example. So it's here you'd see something saying simplify the following expression to one trigonometric term, but this one, because it's in yellow, I'd like for you to try out on your own, but I would do number 2 and 3 for you. So with number 2, you would see without using a calculator, determine the value of sine 2 35 degrees minus cos square 35 degrees 4 sine 10 4 sine to the power to 10 degrees cos 10 degrees, right? Now with this one here in trigonometry, generally what you need to always have in mind is that you always try to get to a certain point where you have an identity, or and here the identities that we want to try and get to is either any of these ones over here, right? So here we'd have at the top sine squared 35 degrees minus cos squared 35 degrees. So the first thing that we need to do, maybe let's try and take out the subtraction. So we take out the subtraction so we can have cos squared 35 minus sine squared 35 degrees, right? Which is the same as this one, right? Because at first you had the sine in front and the cos at the back. And the cos had a negative, so you had to remove the negative, right? So now we'd have cos squared 35 minus sine squared 35 degrees. But then at the bottom, you found that it actually it's 4 times sine 10 degrees, cos 10 degrees. What you do have, you can see that you do have sine 10 degrees and cos 10 degrees. So the only way that you can make it into an identity, or to write it in such a way that it simulates an identity, is to take out the 2, because 2 times 2 is 4. So then you would have 2 times 2 sine 10 degrees cos 10 degrees, and because these are the same and here as well, then you can write it as a double angle of cos 2 35 degrees and sine 2 10 degrees, and then you'd find that cos 2 times 35 gives you 70 degrees, 2 times 10, that gives you 20 degrees, and then you also find that, okay, no, I know that when I say 90 minus 20, that gives me 70. So that means that I can have a co-function of a reduction from the reduction formulas that will give me sine 20 degrees, and then that will cross each other out, and then you find that it is minus 1 over 2, right? And it is minus 1 over 2, right? And then we also have the next question, which is number 3. Now with number 3, it seems a bit more complicated. So it says, given cos 26 degrees is equals to m, without using a calculator, determine 2 sine square 77 degrees in terms of m. But remember what I said at the beginning. I said that, okay, here in trigonometry, the whole point is that you need to try and simulate, you need to try and simulate and reproduce a particular trigonometric function. So in this case, we do have 2 sine to the power 2 77 degrees. So if I have a number which is 2, right, sine to the power 2 with an angle, maybe the best one I can try and simulate is this trigonometric function. So trigonometric identity. So what if I say, no man, I know for a fact that 77 times 2, right, as a double angle would be 154 degrees. That is true, right? You can agree with me on that. So let me rewrite it in such a way that then we have that it is actually 2 sine 77 degrees, right? So what I did was I solved for 2 sine to the power 277 degrees, and then we would find that it's actually 1 minus cos 154 degrees, which, remember, this 154 degrees came from multiplying 77 times 2. But now what can we do? We can actually use a reduction, and when we use that reduction, we find that 180 minus 26 gives us negative cos 26 degrees, which changes it to 1 plus cos 26 degrees. But then at the very beginning, the whole point was us to use 26 degrees, cos 26 degrees, which is equal to m. And they want it in terms of m. And therefore, the answer here would be 1 plus m. And that's how we would do that one. Okay. And now we also look at just the reduction of the compound angles, how we use them. So the ones that are marked in yellow, I'd like for you to maybe just stop the video and try it out on your own. And then if you obviously have problems, you should ask the person who's helping you, or you can send through the questions to us. So now, with number 3, it says we have sine 36 cos 12, that's equals to P, and cos 36 sine 12 is equals to Q, determined in terms of Q and P. So what do we find? Sine 48, we can find that we can separate it into 36 plus 12, and that when we just apply the compound angle identity, and then we'll find that it's actually just P plus Q, right? And that's how you do it. But I'd like for you to try it, see on your own. Okay, and then we move on to 3D and 2D problems, 2 and 3D problems. So basically, these are the types of problems that you would be faced with, right? So in the diagram below, P is a negative 15 to M. That's a point on the Cartesian plane, and it's in the third quadrant. And then they say that 17 cos beta plus 15 is equals to 0. So what can we do in this case? So what can we do in this case? The first thing that you always need to think of, which we will do in the following first question, is to find all the necessary values, and I'll show you which of these necessary values. So without using a calculator, determine the value m and sine beta plus b, right? So the ones that are marked with yellow, I'd like for you to try it on your own, so you stop the video and try it on your own, okay? But with 7.1, we have 7.1.1, so it says given, right? Given, okay, to find m, we want m, right? So this is 7.1. So to find m, what should we notice? We are given that 17 cos beta is plus 15 is equals to 0. So we rewrite that, and we find that the adjacent over the hypotenuse, which in terms of Cartesian plane is x over r, our r, which is our radius, is actually equals to 17, and our 15 is actually equals to our x, right? So therefore we have that, and so we want y, right? Because remember, m is part of, it's a y value, right, in terms of x maps y, right? So we find our y value that it's -8, but be careful. When you square root, you need to be careful at which quadrant it is in, right? Remember, this one is in the third quadrant, and this means it's all negatives, negative y's that are going down. Therefore, it's supposed to be a negative value, so it's a -8 and not positive, or not plus minus 8, just -8. So m is -8 in this case, and you'd find that that's how you did it. But now the important values that you need to find in this type of question is what? You need to find your x, your y, and your r, so that you can use those two things and to calculate the rest. In this case, when you try and calculate sine beta plus tan beta, then it would be very easy, where you just look for your sine here. In this case, what would be your sine? There's the angle, so it would be -8/17, right? So -8/17 plus -8/-15, and then you'd add that together and you'd find the values, right? And then we have another question where I think it's quite important for you to see is that, okay, one, we have that it says in the diagram below, ABCD is an isosceles. D lies on BC. AB is equals to AC, which is ADA. AD is equals to DC, which is equals to B, and the angle B is equals to theta, right? So it says here, determine without reasons the size of the angle ADC. And where's that angle? It is ADC, which I had already done. So in actual fact, how would we determine this without reasons? You can see that we have two isosceles triangles, so therefore we would say isosceles triangles. Remember the properties of an isosceles triangles. It says that basically the two sides are equal, but also the two angles are equal. Therefore, we'd have theta and theta down there. But then at the same time, you do find that in triangle A, D, and C, you have B, that is and B and B, so that is also equal. Therefore, it also makes it an isosceles triangle. Therefore, the two base angles should be equal to each other. So you have theta, theta, and theta there. Therefore, use the normal 180 degrees is equals to all the triangle, all the angles in the triangle. So all the angles in the triangle is equal to 180. You find that 180 minus 2 theta, right? And that would be this angle, which is the angle ADC, right? But now they ask you to prove that cos 2 theta is equal to a to the power 2 divided by 2 to the 2 times b to the power 2, that is all subtracted by -1, right? Now, how would we do this? Now, in this case, when you're looking at these types of questions, you need to remember your grade 11 work, where you need to think about the cosine rule, sine rule, and maybe in some cases your area rules, right? So it's very important to remember. But in this case, what we would use is actually the cosine rule. And the cosine rule basically says that the opposite angle, this opposite angle, so this is the angle that we're looking at, we would equate, we would say that it's A, which is opposite to the angle, right? And then the angles, the adjacent sides, and then we'd add with the adjacent sides to the angle, and this is the adjacent side to the angle, right? And the adjacent side to the angle, and then we'd say -2, and then we multiply the adjacent sides, which is B and B, and then that's how we'd find it, right? So basically, that's how we found it. And so it's in triangle ADC, and then we just simplify, and as we simplify along, we would find that at the end it does give us a squared over b squared. Sorry, that's 2b squared minus 1, right? And then lastly, you can see that I've just summarized those important things: the negative, the identities, and also the sine rule, area rule, and cosine rule. And then we have lastly a question that I'd like for you to try out mostly on your own. So the first part is written, but generally I'll only give you 7.1, and 7.1 would give you that answer, which is a K. But I'd like for you to try it all on your own. And other than that, I really hope that these videos are helpful, and I wish you the very best. Please try these out on your own. And if you have problems, obviously ask the person who's helping you, or other than that, send it through to us. Thank you, and I wish you the very best. Thank you. Good luck. Bye bye.